Okay, so in this video I wanted to address a homework problem that typically causes some confusion. It's asking us to determine which of any of these statements are equivalent. So what I'd like you to do is notice that each of these statements could be rewritten symbolically. So let's take a look at the first statement. If, then. Notice an if-then statement implies it's a conditional using the single arrow. Anytime you see if, then, you want to use that conditional statement. On the other hand, if it had said if and only if, I would have used the double arrow. Okay. So she is happy. I'm going to let that be P. And again, it could be he or she, whoever. The idea is someone who is happy. So if P, then she frowns. So I'm going to use, let's see, we'll find another fun color here. How about we'll use purple. Hopefully you can tell the difference in my video here. Okay. So she frowns. So if I'm letting P be she is happy, this would be if P, then she frowns, then Q. So I'm letting this statement be my Q, and I'm letting she is happy be my P. Okay, if P, then Q. Hopefully that makes sense. All right, so they asked us in the directions, I didn't write it on here, but they asked us to determine if these are equivalent. Now, one thing you could always do, just so you know, is you could create a truth table for each of these statements as one of the columns of your truth table, and if they're identical columns, then you know that they're equivalent. However, I believe they asked in the instructions for this particular problem if we could use De Morgan's law. And remember De Morgan's law, let me write it down here. De Morgan's law works for equivalent statements when you're talking about negating an and statement or negating an or statement. So if I had, let's say, not negation of P and Q, what would that be with De Morgan's law? Just to review real quick. Okay, so with De Morgan's law, that says we would basically distribute the negation sign, right? Distribute the negation sign. So this would become negation of P, so not P, negation of Q, so not Q. But what happens inside? Do you remember? That's right. If you're using De Morgan's law, you have to flip the connective. Very good. So this and becomes or, right? Similarly, if I had negation of an or statement, let's say P or Q, what would De Morgan's law tell us here? It would say it's equivalent to distributing the negation to each of these, but flipping the connective. See if you can write that one yourself, just from memory. That's right, exactly. Negation of P, negation of Q. What happens to the connective in the middle? The or becomes what? If you said and, you're correct. You flipped the negation. Okay, so with that in mind, that's what they mean by De Morgan's law, okay? De Morgan's law is when I am negating an and or negating an or. Now, there's one other equivalency that might come in handy here when you have an if-then. Notice that's what we have here for statement A. We have an if-then. If she is happy, then she frowns. We also learned that an if-then statement, another common equivalence, was if I had an if-then statement, so something implies something else, and if the first antecedent, the condition, was P, and if the consequent, or the expectation, was Q, that was equivalent to what? Do you remember? That was equivalent, technically by De Morgan's law, of negating a conditional statement. And what it ended up being was negation of P. I should be more consistent here. I put P in pink, so let me clean that up for us. Negation of P or Q. And remember, you can have this on a note card, all of these equivalencies, to keep yourself organized. Negation of P or Q. Let's think that through, why that works, okay? That's kind of a tricky one to understand. It's saying, it means the same thing to say, if she is happy, then she frowns. If she is happy, then she frowns. That means the same thing as saying, she was not happy or else she frowned. right? She was not happy or else she frowned. So it's kind of like if P was you have an iPhone and Q was it has Siri, it would say if you have an iPhone, then it has Siri. That means the same thing as saying either it's not an iPhone or else it would have Siri, right? So this is equivalent, and we could test that using a truth table. But with those in mind, let's see if we can find any equivalencies with A, B, and C. We've already translated A symbolically because it's an if then, if P then Q. Let's take a look at how I would translate statement B symbolically. It is false that, okay, so as soon as they say it is false, that means what? Negation, good job. So that means negation of something. What's false? It is false that she is happy and frowns. So those two things are together, aren't they? When you have those two things together, and how do I know that? Because it's saying that whatever comes after false is together, right? It is false that what? That she is happy and frowns. So to put something together like that, we could use like parentheses, right? That she is happy and frowns. So we're going to use parentheses. So it is false, so it's not true, that she is happy and frowns. Well, the letter for she is happy, we said was letter P. I'll use pink for that. So P. And uses the connective like this, right? And. Okay. Frowns, we said was the letter Q in purple, right? Okay. So this is saying it is not the case, or it is false, that she is happy and frowns. Okay. So let's take a look and see if we could use De Morgan's law and find something that would be equivalent to. Well, we know that should be equivalent to, if we look down here, that should be equivalent to negating each of them, negation of P, negation of Q, but flipping and into or. So if that is what we see in part C, then we have an equivalency with B and C. Let's take a look if that's what we have here. So we have, the statement here is B, negation of parentheses, P and Q. Let's look at C now, ready? Here we go. She is not happy, and she did not frown, or she is not frowning. Doesn't matter which tense you use here. Well, I see negation, do you? Yeah, I see a negation. So she is not, so that's a negation. Happy. Happy was letter P, so she's not happy. And, I'm going to use my and symbol. She did not frown, or she is not frowning. So negation again for the not. Not. Frowning was letter P in purple. Sorry, I said P, but I meant Q. I apologize. Let's fix that. Letter Q in purple. All right. So what do we know here? Well, that kind of looks like B, doesn't it? Where you distribute it. But what's not quite right for De Morgan's law? You have it on the screen here. Do you see it? Right, that's correct. For De Morgan's law to apply, not only do you have to distribute the negation to each letter in parentheses, but you also have to notice that you flip the connective. So for example here, negation of an and becomes the negations of each of them, but connected by an or. And that's not what happens here. So in C, that's not equivalent to B. Do you see why? Because these are not opposite, they're not flipped. So we know for sure that B and C are not equivalent, okay? Now notice also what would have to be true for A to be equivalent to one of these. According to the third equivalency that I wrote down here, P then Q is equivalent to negation of P or Q. Now we have negation of P in part C, but we don't have an or, and we also don't have a Q. So even if this was a regular Q, not a negated Q, this would still not be equivalent because this is an and we would need it to be an or. So we also can see here that A is not equivalent to C. So if A is not equivalent to C and B is not equivalent to C, what else could we check? Well, we could check if A is equivalent to B, right? And again, P then Q is equivalent to not P or Q. But that's not what we have here, right? If we were to distribute here, according to De Morgan's law, this would be negation of P, negation of Q, but the connective would flip into an or, okay? Now, is that the same thing as A? Let's take a look. If P then Q is the same as not P or Q, I see not P, I see or, but do I have regular Q? I do not. So I can tell here that A is also not equivalent to B. Now, if you didn't like the way I did this, if this was a little too confusing, remember, you always have the option to construct a truth table. You would need a P column, a Q column, You would need 4 rows because there's 2 letters and 2 to the second power is 4. And then you would need to carefully construct a column for this statement, P then Q. You'd have to work your way up to this statement by doing a P and Q column and then a negation of that. So that'd be 2 columns you need to get there. And then for this one, you would actually need to build your way up to it by doing a not P column, a not Q column, and then putting them together with and. Finally, you would compare the column for each of these final statements and see if they're identical. And what you'll find is that there's going to be at least one place where they're not exactly the same. And in order to be equivalent, they have to be exactly true and false in exactly the same places. All right, well, I hope that was helpful for you. If you have any other questions, feel free to reach out to me. But in the meantime, make sure to practice because math is not a spectator sport. I'll see you next time.